make a direct control between robot and board. So I will outline it in short time. So at first I give a small problem description of the problem which the student has to solve, an overview of the sensor what we're using for, where we have posted or packed the sensor in our robot, and some first results of the project. So at the beginning, so the main goal was how the ball rotates, what is the speed limit for the sensor you can measure of the rotation of the ball. Depending on light conditions, how the sensor reacts, like vision control and fall detecting, I think same procedure. And how accurate the sensor is or the values are, so that we have a value for compare, that we can compare different values. And finally, it has to code an active control, like an EasyPDD controller that robot never holds the ball, so he's every time he's dribbling or controlling the ball. At first, I will give an overview of the sensor. It is an ADNS 3080 from Arago. It's like a standard mouse sensor, and here's some overview of the performance. The maximum velocity he can measure 40 inches per second. The maximum acceleration is up to 15 G, and gives a small image from 30 pixels, but it's in grayscale location. The frame rate is very high, so we can measure very fast the pictures over SPI, and the standard supply voltage. The positioning in our robot, so therefore the robot here is we post it in the kicker, so on the side of the kicker. It is here, and because we need a special distance depending on the length of the sensor that we detect in a certain area and get a good quality of service value of the sensor. So as well, we have here an LED, because depending on the light condition, it's possible that the sensor cannot see the image fine. So therefore, we also add here, you can see here a small LED. And at the moment, we have a red LED, but it's also possible to use some LEDs in not visible red, so that nobody is disturbed from the slide. And so therefore we have to set up the position of the lens so that we have a sharp image and focus the ball fine. So I will present the first results of this project. So we can see an image what we grabbed from the sensor. It's a little bit dark here, so my PC was a little bit better, but I think it was this bottle. So we can see this W here. So we have focused here is the bottle, and see we can configure that it's sharp, the image. And afterwards we take the autometry of the robot, because it's so in our case we use this Maximotors, and this autometry is very accurate, and use this motion value as ground truth, that we said, okay, this is our real velocity we have at the moment, and make measurements for some rotation. So we check that the ball is fine in the kicker and rotates. So for velocity, and use our motion, so we drive by a keyboard and check these values. So we have here the values. So delta x is the velocity that we have in x direction. Our x direction is this direction of robot, and our y direction. So it's like the front direction of the board of the robot. So the red one is our quality of service. So you can see that the quality of service has a lot of noise, because the ball is like, if we dribble, the ball is moving a little bit, so front to back, and therefore the focus is not very good. So for this reason of the jumping ball, we only take the best, or we like to take only the best quality of service values for active controlling. I think this is the final result of the project. So he tries to find from rotations of ball, calculate backwards what motor values we have to set, and the velocities, what we guess the ball is rotating. So this is now the the final result of this project, that we measured some motor values, some rotations what the ball has. In using also the keyboard for different velocities and make a lot of measurements and to print out what the sensor measures and mean if we take the best quality of service. So I think at the moment the progress is to code a PID controller to use it in RoboCup. So like I said before, I think the main problem we have to figure out how good it works is the moment then we think we have the ball. I don't know what the rest of teams using for what values they use for vision positions, so that said, okay, the position is very close to me, so I know I have the ball, or a special sensor. So this is sometimes our problem, that the ball is jumping a little bit in vision and we don't know really when we have the ball. So when we control, it jumps a little bit. So it was the first test of the controller, and that's all the status of this project.
First question: do you keep your lighting system, your LED, on all the time, or only when you have the ball? The behavior is coded that only if we have the ball we put the light on. Okay.
Yeah, because
so it actually doesn't matter if it's red or infrared or other, because the fact is most of the image sensors actually respond to a certain degree to infrared. So changing to infrared, okay, we couldn't see, but the image sensors would make any difference. It's better to take it, have it off until you have the ball, and then.
Sure, for testing, But we control it like this, but if we have the ball, so then we put the light on, because else we don't need it.
I believe your vision is anyway calibrated to detect infrared balls, right?
Infrared balls. No, it's not calibrated for that, of course. But it's nice. It's very simple to make and show to our students how the sensors work, because there is infrared TV command, for instance, okay, and you put one of these phones, cameras or something, look into it and you press it, you clearly see the LED blinking. Okay, so changing the LED for an infrared one, because otherwise if you go too deep into the infrared spectrum, your own sensor won't capture the back illumination. So the idea is, okay, you can shift to the infrared, but within a range that other sensors will also capture that information. So it won't make any difference, actually.
Could you go back to the specifications of the sensor?
Yeah.
Do you know what the variation in the distance from the sensor is? What kind of variation?
I don't remember. That's described in the data sheet. I can send it to you if you like. I don't remember really. So we bought some different lenses to make some experiments with it. So that we can. The main idea was that we have 3 different lenses for different positions, that we can check if it's better put the sensor more on the back or more on the front, depending on the light conditions.
This is a black and white image, right?
Yeah.
Because we had also the same idea, however, not for the ball but for traction. So you know your absolute position, you can compare it with the encoder, so you know when you slip or not. However, we found a problem. We just use a computer mouse, but if you use take a computer mouse and you lift it just a millimeter, it doesn't work anymore. And if you then do it, the robot does this all the time when it's driving. So we didn't get an accurate measurement about the displacement. So therefore, I was wondering what kind of sensor you use, and if you can cope with that. Variation.
Yeah, I think the main problem is the focus, where you set the focus of the. So a mouse sensor is defined the focus because it depends on the distance. Therefore, we have this this small lens. Here's a small lens, and we can we calibrate the lens a little bit. So depending on the ball, put the ball there, move the lens a little bit, then we have a look on the picture and look that the picture is very sharp. So then I think was for our experiments yet the best solution. So if the ball jumps a little bit, the ball gets a little bit unsharp, but still the quality of service value, it's okay. So it depends. So some centimeters were okay, but if it's, I think up to 3-4 centimeters was bad. So some people use the sensor also to use the distance to the ball, so to detect the distance to the ball. They use it by a different way, but also I think it's possible. So depending on the quality of service, you can measure distance to ball. So it's not very accurate, but yeah.
But are there sensors available which could auto-adjust? They can adjust the sharpness automatically?
No, it's manual. Yeah, it's a lens and yeah, it's a screw lens, so you can.
Yeah, but maybe there are also for this size also. Yeah, okay.
So it's very easy.
That's no problem.
Actually, takes the pictures, you can print the pictures. Also, it's an idea like to make an own detection of rotation of the ball, because the main problem is, so like moving the ball is, normally the ball is moving forward, and so sidewards also we can detect fine, but in between there we have some problems because the mouse can recognize these values. It's like you take a mouse and rotate it. And this is the mouse is not.
Okay, obviously if the ball is rotating on the axis that's with where the end is at the middle of the sensor, then it's rotating this way.
Yeah. You cannot see rotation.
You cannot see the rotation.
Yeah.
But in our case, it normally takes a forward movement, so we ignore it. But also, it's possible to take the image and make an own rotation on the microphone. So
if you can you maybe solve the problem instead of looking exactly at the middle of the ball when it's rotating like this, look a little bit out of the middle. You know the distance from the middle, so you also know the rotation. You can derive rotation back from the middle of the ball.
I guess you could also use two
sensors.
Of course, yeah, two also.
But
Two is even better.
Yeah, I think $40 or around.
How many?
I think $40 around.
40.
Yeah, I'm not very sure.
Yeah.
With the lens.
With one lens, I think 8 millimeters was the lens at the beginning, and then we bought for I think 5-6 euros another lens, or for every lens 5-6 euros for testing, so that we can.
So you suggest to design a PID controller.
That's the way to do it.
Yeah.
Cheap.
And the signal that you use to control the motor is voltage. So that's actually a current that's actually directly steering the torque to the motor, right?
No, we have already a clear control and using the odometry. So from the odometry we have a value what the motor controller thinks we are driving forward.
Yeah, but now I'm talking about the PID controller that you want to build for this sensor.
Okay, yeah.
So you will be steering the speed of the wheels, right?
Yeah.
The ball handling wheels.
Yeah.
So the input there will be the voltage, which is translated via current to torque. So actually you're steering torque. You're measuring velocity, and in between torque and velocity there's only a single integrator. So you could expect that perhaps only a P controller would be enough.
Yes.
Probably.
Probably just a PD.
So my question was why do you need a
probably
PID?
be enough for this application.
And only of course there is delay in the system, so if you really want to obtain a high bandwidth, you will get the instrument
So much
So I think it's a D Okay, it's not very sure that you will actually need all three ingredients.
Yes, of course.
Okay.
So I will start with a P, proportional control, and that would be already enough.
Yeah, of course.
Most probably.
Because in theory that can never lead to the stable system if there would not be any delay in the loop, of course. That's why eventually you will lose so much phase that would be that you need some differentiation.
But in the end, you can add a difference, a small d into integration if you need.
Probably you will be.
Yeah, probably.
Also, what is the frame rate that you're using? The current frame rate, are you using it to the maximum frame rate?
I think we
40 FPS.
No, I'm talking about the internal frame rate.
This makes me better. I think we use 200 FPS, I think, because it's still enough. So we take the sum of it, and this we share over the canvas to our PC. So every
Yeah. Get yeah.
yeah, because every part of us is connected to the canvas, and
Yes.
this value we share every 30 milliseconds, and yeah, make a mean of I think 200 FPS.
Yes, but the sensor apparently has an internal image processor, right?
Yeah.
So you can get only information about the motion flow, right?
Yeah.
You don't need to actually add the images.
No,
Yeah.
at the moment, yeah,
Only
we
for
have-
vibration.
Yeah.
We only send this values, so like X, Y, and quality source.
Yeah.
Okay, because if you used more frame rate, if it was possible, can you show the plot? The plot?
The plot of
Yeah, of the results.
this one.
You see,
Yeah.
those are 1,500 samples.
Yeah.
If you were using the maximum frame rate, that's a third of a second. And all that jitter, you could only integrate that. I don't know what kind of precision are you seeking for, but that a third of a second, I think was enough for this application. And you would get rid of all that noise.
Yeah. So sampling with a lower, you mean that a lower frame rate will be enough because
High.
No, a high frame
a
rate.
higher frame rate we will raise the jitter. Yeah. I remember that the student has some problems with higher frame rates, so we have to check it. But so for this reason he selects a middle frame rate of the sensor. But yeah, we'll try.